Alright, so we talked about graphing linear inequalities on Thursday. Right? Friday to our code. On Thursday. Today we're talking about systems of linear inequalities. We're going to have more than one linear inequality they have to put on the graph. So, a system of linear inequalities consists of at least two inequalities in the same variables. So that means that they have the same exact variables and you have two or more inequalities, right? The solution is the ordered pair that is a solution to all inequalities in the system, which means when you go to graph it, your solution set is going to be where they overlap. Alright, so normally we would shade one side of each line. Well, where those two shaded regions overlap is going to be what we call our solution set. Alright, I don't think we'll ever have more than two inequalities in our system. Alright, we're going to do a couple problems today where they both have two. I didn't look at the homework, so that might have it, but I don't think on the test we have more than two inequalities in one system. Alright, you could, like all of these ones have, well, this one's got three, that one's got three, that one's only got two, it looks like, but we won't have more than two normally. Alright, so what's going to happen is we're going to graph them, we're going to shade them, and the overlapped region is going to be our solution set. So, if you look at the first one here, so like I said, the picture on your paper doesn't look as nice as the one up here. Right? You can kind of see up here, we have a dashed line here that's shaded to the left, and I have a solid line here that's shaded down. What happens is our solution set is right where they overlap, in this little triangle here. Alright? So if we're looking for solutions, we got to see, well, they give us 5 points, right? We got to see, are those points inside that solution set, inside that double shaded region? Well, if I look at 0, 0, on my graph that's right here, does that fit both inequalities? No, it fits the green one, but it doesn't fit that blue one. It's not in the double shaded region, so no. That is not a solution to the set. It needs to satisfy both of the inequalities. Well, 0, negative 6. 0, 1, 2, 3, 4, 5, 6. Ooh. That one's really close. It's right on that solid line. So will we include it? Yeah, right? It's a solution to our set because it falls on the solid line in the double shaded region. Hey, what would have happened if it was on the dashed line? It would have been no, right? We can't include things on a dashed line. We talked about that on Thursday. Negative 6, 0. 1, 2, 3, 4, 5, 6. Negative 6, 0. No, right? It's just in the green again. What about like 1, negative 7? So 1, 1, 2, 3, 4, 5, 6, 7. 1, negative 7. This dot right down here. And?
Why can't you include things on the dotted line?
Because remember, a dotted line is just like an open circle where it's just less than or just greater than. It's not or equal to. So just like that open circle, that dotted line says that's my boundary, but I can't actually include the things on it because it's not or equal to. Okay? Alright, 1, negative 7. Yes or no to solution?
No.
No, right? It's only in the blue. It's not in that double shaded region here. So no. And then negative 2, negative 7. So 1, 2, 1, 2, 3, 4, 5, 6, 7. In there. Negative 2, negative 7? Yes. So anywhere we see a double shaded region is going to be what we call our solution set. Now, when you graph them, it's going to be way easier to see where your solution sets are because we're going to do it a little bit different than how they have it up here. Okay? Cool?
Cool.
Sweet. Alright, so writing inequalities. Like I said, we did this with our bell ringer a little bit. When we're looking at least, looking for keywords in our inequalities, at least is going to mean greater than or equal to, right? I can make at least $500. I need to make at least $500. That means at the minimum, I can make 500, or I can make above it. So I can make equal to 500 or greater than. So greater than or equal to. No more than. That means I can make that much or less than it. So it'd be less than or equal to. We're looking for these keywords, guys, in our problems. More than and less than are pretty self-explanatory. More than would mean greater than. Less than would mean less than. Stays the same. So those are some of the keywords we're going to see in our problems when we're trying to write our inequalities. I can guarantee you, I believe there's at least one problem, there might be two. I think there's only one, maybe. That where you're going to have to write your own inequalities on the test. Alright? Okay? We may also ask you, like, what's a solution to a certain set or to a certain graph of a system? You need to know that the double shaded area is what we're looking for. Alright, do we all have that down? Sweet. So, let's look at our first example in class. We're saving money for a new car. You can work a total of no more than 40 hours each week at your two jobs. House cleaning pays $5 per hour. Your sales job pays $10 per hour. You need to earn at least $255 each week to pay your bills. Write a system of inequalities that shows the various number of hours you can work at each job. Whenever you are doing an example, you should always label your variables first. Now, I'm always going to use X and Y, just because that's what makes it easy for me. So, I'm going to let X be the number of hours house cleaning, and Y be the number of hours for my sales job. Because I'm talking about two different things here. Right? In this problem, I'm talking about the number of hours that I work, and the amount of money I make. So that's how I'm going to write my two inequalities. I'm going to use one where it's going to be the number of hours I work, and I'm going to write one where it's the amount of money I'm making. Does that make sense?
Yes.
Those are the two separate things I'm talking about. Well, what are some important facts that we had in this little paragraph here? No more than 40 hours. I'm going to underline that. No more than 40 hours. Okay? What else is important? House cleaning pays $5 per hour. Sales job pays $10 per hour. What else is important? At least $255. Okay, so I think I got everything figured out here. Yes, Johnny?
Can I go to the bathroom, please?
Do you have your passbook?
Oh, yeah.
Sweet, can you fill it up? Alright, if I want to write an inequality for how much I'm going to work in a week, what can I write? Well, I know it has to be no more than 40 hours. Well, what is no more than going to be? Less than or equal to 40. Right? I know I can work up to 40, or I can work less than 40, but I can work no more than that 40 hours. So it's got to be less than or equal to 40. But where do my variables go? How do I know how many hours I'm working? X plus Y, right? X is the number of hours I spent house cleaning, plus Y is the number of hours I spent at my sales job. So the 2 hours that I work, right, hours at house cleaning, hours at sales job, can be no more than 40 hours in the week. So that's my first inequality. Okay? Well, let's look at the second part, the one I underlined in red. House cleaning pays $5 per hour, sales job pays $10 per hour. I need to earn at least $255. Let's look at that last part. At least $255. Well, at least is going to be what kind of inequality? Not less than or equal to. Greater than or equal to, right? At least would mean, at least is like at the bare minimum. I need to make $255 to pay for my stuff, right? I could make more than $255 and I'd be perfectly happy. But I need to make at least that $255. So I can make greater than or equal to $255. Well, using my variables, how can I figure out how much I made? Sid, how'd you get 5x plus 10y? Good, right? I get paid $5 every hour I spend house cleaning. So $5 per house cleaning hour, well, X is the number of hours. So 5 times however many hours I spend house cleaning. Plus 10y. I get $10 for every hour I work my sales job. So if I work my sales job Y hours, I'm going to do 10 times Y. Right? Does that make sense how we found the two inequalities?
Yeah.
Right? Figure out what you're looking at. Well, we saw we were looking at the number of hours and the amount of money. So it's easy to figure out. Alright. So that's our system of inequalities right there. We have two inequalities. Let's graph them. Alright. if you look at our graphs, so x plus y is less than or equal to 40, 5x plus 10y is greater than or equal to 255. Am I ever going to work like negative hours? No, so what's going to happen is I'm just going to have positive values along my x and y axis. Now, once again, I really don't care what you go by, as long as it's a constant scale. I'm going to go by 5s every other line down here. It's like 5, 10, 15, 20, so on and so forth, 30, 35, 40, 45. Okay, so that's my x-axis. My y-axis, I'm going to do the same thing. 5, 10, 15. All right. Now what I'm going to do is I need to graph my two lines. So you can either do the cover-up method for each one, or you can solve each one for y. You want to solve for y? That's fine, we can do that. So I'm going to subtract x here. Y is less than or equal to negative x plus 40. Okay. What does that tell me about that first inequality here? The y-intercept's 40. So my y-intercept, I'm going to do this, the first graph's going to be red, I'll do my second one blue. Obviously you might not have the opportunity to do two different colors. But, alright, so, what does that tell me about my slope? What's my slope? Okay. The one tricky thing with doing it like this, guys, is your slope doesn't always match your scale, right? So if you do y equals mx plus b, you may have to scale it up a little bit, right? Like I can go down 5 over 5. I can't really go down 1 over 1, right? I don't have that ability here. Now, so that's why I would suggest maybe doing the cover-up method for problems like this, but we can make this work, all right? So instead of going down 1, I'm going to go down 5, and I'm going to go over 5. Go down 5, over 5, right? Because that's the same as going down 1 over 1, down 1 over 1. Does that make sense? Why that won't always work? If I go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down over, I go down 5 and over 5 anyway, right? But because my scale is by 5s, I have to do it that way, right? So your scale might not always match your slope, which could create issues. So you might have to try doing the cover-up method. All right? Okay. So is this going to be a dashed or a solid line here? Solid line. That one, and I want red. Okay. So we need to figure out which way we're supposed to shade this inequality. So take your test point. 0, 0. I'm going to do it down here because I don't have much room to go off. Test point of 0, 0. I get 0 plus 0. Was it less than or equal to 40? So 0 is less than or equal to 40. Is that true? Yes. So instead of shading it, I'm going to just draw a few lines going that direction towards 0, 0. So that's the side I would normally shade. Because remember, we're looking for the double shaded region. So we just need to see where both of them go. So I would not completely shade it because it's going to be really hard to see the double shaded region then. Okay? If you want to lightly shade it or just do these lines, that'd be the best bet. Alright, the second one. How am I going to do that? Should we solve for, you guys want to try and solve for y or do you want to cover up?
Y.
Okay, we'll solve for y again for this one, but then the next problem we're going to cover up for both of them. Okay, deal? Alright, so if I solve for y, I subtract 5x. I get 10y greater than or equal to negative 5x plus 255. Right, then what do I do? Divide by 10. Y greater than or equal to negative 1/2 x plus 25.5.
Can we keep it at negative 5/10? Because
You could leave it as negative 5/10 for your scale reasons. When you write your answer, so it'll probably ask you for, well, no, because we could have already written this out. If you have that written out already, that's good, and then when you change it, you can leave it as negative 5/10. I'll give you that. Okay. Am I going to be able to get exactly 25.5 on my y-axis? No. It's an estimate. Do your best, right? If you put it really close to 30, obviously that's not okay. But if you're close to 25, you're just above it, right? It's fine. Do your best. It's an estimate. So 25.5 is right about here-ish, right? So I'm going down 1 over 2, except my scale is by 5s. So I'm going down 5
Over 10.
to the right 10. Down 5 to the right 10. One more time, down 5. Oh shoot, where'd I go? Right here. 1, 2. Okay. Is this going to be a dashed or solid line? Solid. It's or equal to, right? So if I put my line in there, blue, sweet. Alright, so my blue line is in there. Now, guys, when we do problems like this, if you don't have arrows, that's okay. Why would I say that's okay? No, it is. It's if you don't have arrows on a problem like this, where we do a system of inequalities, where we can only have positive values, Aiden, why would that be okay?
Because if we're doing like in the overlapping areas, they don't go infinitely.
Now that's, okay, that's true, but I wouldn't say that's the reason. Okay, TJ?
Values can't be negative.
The values can't be negative, right? So if you keep your lines going, you're going to end up getting to the negative y values. You're going to get to the negative x values, right? It's like Aiden said, it's going to stop here because it can't go negative for x values. Or if you're going to go down, it can't go negative because you can't have negative hours worked. It doesn't make any sense. So if you just put them to the end of the graph, I'm perfectly okay with that. Now I drew arrows on them. I probably wouldn't mark it wrong if I put arrows on them, but in this case you don't have to. Normally you do, in these problems you don't. Alright, so test point 0, 0. 5 times 0 plus 10 times 0 greater than or equal to 255 is 0. Greater than or equal to 255.
No.
No, it is false. So that means I'm going to shade opposite of 0, 0. So what you need to do then, once you figure out which way they both shade, is you need to really darken that double shaded region. So in this case, it's right here. Because that is our solution set. That is where it will satisfy both of our inequalities. So I need to be able to see where your double shaded region is. Make sure it stands out. Alright, and then if I was to ask you, what is one point that would satisfy this solution set?
10, 30.
10, 30. Perfect. Say work 10 hours at, what was X, their house cleaning job, 30 hours at their sales job. Perfect. You just got to pick one point out of that double shaded region. Alright? Does that make sense? Do you have a question, sir?
Yeah, so like, what do you put for the answer then?
So, well, in this case, if it had asked us, what's one solution? And you said 1030, right? In this case, that's name a point. That's in your solution set. Just name the point. If it asked you, like, how many hours would you have to work at both jobs to make it work? Then you'd put, like, 10 hours house cleaning, because that was your X value, and 30 hours at a sales job, because that was your Y value. Okay? All right. Any other questions? Okay, we have one more problem. Oh, Aiden?
1030 doesn't work as a point if you use it mathematically. Like if you enter it into the inequality.
Are you sure?
Yeah, my calculator I got, if you work 10 hours in your sales job and 30 hours in your cleaning job, you'd only get 250. That's what I got.
So, are you sure you didn't do 10, did you do 10 and 20? Because that'd be 250. There should be 50 plus 300 if you do 10 and 30.
Yeah, I'm pretty sure I got it right. I might have done something wrong. Yeah, I probably did. but
Okay.
I,
Yeah, because if you get 250 here, I would assume you did 10 and 20. Because if I put 5 times 10 should give me 50. If I do 10 times 30, that should give me 300. So that should give me 350, which should work. Okay? So just be careful if you like plug them into your calculator, make sure you put them in correctly. Okay? Alright. Any other questions? Okay, we have one more to do. And I want to go through it quickly so we can have some time to recess because actually we're running out of time already. Weird. Alright. There are at least 6 pounds of ham and chicken in the salad. Right? At least 6 pounds of ham and chicken. Ham costs $3 per pound. Chicken costs $4 per pound. The most you can spend on meat for the salad is $36. The most. Write and graph the system of inequalities that represents the situation. Alright. So, I'm going to let X be pounds of ham. I'm going to let Y be pounds of chicken. Right? So we're talking about two different things here. We're talking about how much of each we have. And we're talking about the price of each. So if I look at the first part, there are at least 6 pounds of ham and chicken, which means what type of inequality should be used? Greater than or equal to 6. It could be at least 6 or it could be more. Well, how do I know how much ham and chicken I have? X plus Y, right? Pounds per plus pounds. Alright? Then I'm looking. At most, I can spend $36. At the most, I can spend $36. That means I can spend less than or equal to 36. Well, how much does ham cost?
$3 per pound.
$3 per pound, or 3x. Plus, how much does chicken cost? $4 per pound, so plus 4y. Why are we running out of time so fast? Does everyone understand how we got those inequalities?
Yes, sir.
Alright. So should we try and like do a graph or something?
Maybe.
Maybe? Alright. So, oh, I think we have it up here already for us. I want to do it, so. So we had x plus y was greater than or equal to 6. 3x plus 4y less than or equal to what? 36. Alright. So, I said I was going to cover up method for this. I'm going to go by ones, but I'm only going to write every other one. So 2, 4, 6, 8, 10, 12, 14, 16. 2, 4, 6, 8, 10. Alright, so I'm going to do the cover up method. The first graph I'm going to do in green, the second one I'll do in a different color. If I let x equal 0 in this first equation, my y value is going to equal 6. Right? Because I'm pretending it's an equation right now. I'm looking at it like x plus y equals 6, so I can graph it. So if I let x equal 0, y should equal 6. My first point should be at 0, 6. If I let y equal 0, x equals 6. So I get 6, 0. It's my second point for the first equation. Is it going to be a solid or dashed line? Solid, because it's greater than or equal to. Green, right? Okay. Does everyone understand how we did that?
No.
So remember, we're looking at this inequality like it's an equation, correct? So for the cover-up, I let x equal 0. Well, if x is 0, I can just cover it up. I'm left with y equals 6. So that's my y value, 0, 6. If I let y equal 0, I can just cover it up. I'm left with x equals 6. So that's my x value. So I got 6, 0, and I got 0, 6. Right, so for the cover-up, we're looking for the two intercepts. Okay?
How do you know if this is ham or chicken?
Well, remember we gave our two variables names. We said that x was ham and y was chicken. So it's the same thing over here. When I go to graph it, my x-axis is telling me how much ham I have. My y-axis is telling me chicken. If you want to label them, you can. I won't take points off if you don't. Then the second equation, 3x plus 4y equals 36, right? We're trying to make it like it's an equation. If I let x equal 0, I cover it up because 3 times 0 is 0. I'm left with 4y equals 36. If I try and divide by 4, I get y is 9. So at 0, 9, I have my first point. Then I let y equal 0. I'm going to do it over here. 4 times 0 is 0, so I cover it up. I'm left with 3x equals 36. Divide by 3. X equals 12. So at 12, 0, I have my second point. Okay? So guys, we're looking for the intercepts. We're looking where x and y equals 0. So all you do is you plug it into your equation and you solve it. Okay? So plug 0 in for x, solve it. Plug 0 in for y, solve it. So I have my 2 points. It is a solid line because it's or equal to. Oh, I didn't shade the first one, did I? Did not. So, the first one, if I do a test point of 0, 0, I get 0 plus 0 greater than or equal to 6.
No.
That's false, right? So if I shade away from 0, 0, this first point, or this first line, goes this way.
Can we do this without the cover-up method?
You could do it where you set it equal to y, that's fine.
Yeah, how are you supposed to do it like that?
So, in that case, you just solve for y for both these.
Yeah, but how do you know what to do, like, how do you graph it after that?
Then you just use your y-intercept again, and you use your slope.
But
We'll
how
talk
do you
about
know
it in a
the
second.
equation?
Okay, I'm going to finish this one and then I'll come over. Okay? Alright, second one, if I put a test point in. 0, 0, I get 3 times 0 plus 4 times 0 is less than or equal to 36. Is 0 less than or equal to 36? Yeah, so I'm going to shade my second line. I need to do it in black to be consistent. This way. So my double shaded region then is right in between the two lines. So any point in there will work. Alright? Does that make sense?
Yes.
Do we have any questions on that? Okay.